Hello there. This is stream number 54. And yesterday I dove into TLS, which is Transport Layer Security. And we needed that in order to make secure connections to a web server in order to get stuff securely, I guess. That's what we're doing it for, right? So it was mostly of an experimental nature. So what I did is I ended up making, where did I write this down? I made a decorator for HTTP client transport and subsequently HTTP connection that wrapped an inner transport connection. This is why I call it a decorator, and passed all data through libTLS. So libTLS comes from, I'm getting my libTLS from LibreSSL, although libTLS is more of a generic term because the TLS library could be provided by other things like OpenSSL or BoringSSL, and there's lots of other implementations. I'm using LibreSSL. So I made this decorator because it fit into my web client called Rover pretty nicely. Let's go look at that. Well, let's close all the things from yesterday and just look at Rover and where we set it up. So it's pretty simple to understand what I'm doing here. So if the scheme of the web page we're going to fetch is HTTP, we just use this transport object, which is this class, HTTP Client Network Transport, right? But if it's HTTPS, we still use that transport object, but we make this other thing called a TLS decorator. Decorator pattern basically says you're going to insert a class that has the same interface, but changes the behavior in some way. So TLS decorator implements the same interface as this client network transport, and what behavior changes is it makes the connection secure using transport layer security, which I did not write the implementation of. Again, I'm using LibreSSL's implementation, which is based off of OpenSSL, and it's maintained, LibreSSL 1 is maintained by the OpenBSD folks, which is a sort of a departure from my normal stream. So far, I've done 53 streams, and this is 54, and most of it's been writing code from scratch. In other words, C++ code that's just using standard library, and maybe some operating system libraries, but not using any other open source. So I kind of am deviating from that a little bit for TLS, mostly because TLS is pretty involved, and if you do it wrong, bad things can happen because it involves security. And oh, hey there, Ixter. How's it going? So yeah, we are decorating a transport with this TLS. And so it was really just 4 extra lines of code to insert TLS support, as long as I made my decorator use the same interface that Rover expects, or really that the web client expects. Now that worked out great. We got TLS working. The problem is I want this decorator to support more generic protocols. So right now, because it's decorating the HTTP client network transport, the keywords are HTTP and client. I can only use it with HTTP, and I can only use it for client side, not server. So I want to make it more generic. So I'll need to change the code so that it adapts or decorates basically the lower level class in my hierarchy, which is network connection, and not the upper level HTTP connection. Hey, Rally Monkey. Oh, it didn't switch to me? Yeah, I don't know how the Twitch hosting works in all of its fine detail. Like, it auto-hosts based on who's streaming, and Adam's pretty high up in the list, so it's probably hosting him. And I thought that as soon as I start streaming, maybe a few seconds in, it would switch to me. So I usually start the stream and I kind of pause, or maybe just say what stream number it is. I kind of kill a little bit of time to hoping that the hosting turns off, but maybe I need a better way to see that. Maybe I need to watch myself on the other monitor and see where it switches or something. Also, I think there are some bugs in Twitch. Sometimes, like, you have to refresh to get it to update. I don't know why. So yeah, today I thought I would spend some time taking the Decorator code we wrote yesterday and trying to restructure it to decorate generic network connection, not just HTTP connection. So I guess the primary goal is to free it up from HTTP, and the secondary goal would be to free it up from the fact that it's a client binding, or client interface, so that I can use it with the server. Because the TLS library, I think with only minimal changes we can use this for the server. Where it will change, I think, are where we have words like TLS client. So instead, it's going to be like TLS server instead. And I'm sure we'll have to deal with certificates too. We'll have to have a server certificate and input that and all that good stuff. Not today though. We'll just work on taking this decorator class and pulling it out into something more generic. All right, and I was hoping to have a block diagram to illustrate. Instead, I'm going to use some crude drawing. I'll impress you all with my amazing artistic skill. And I will draw to you for you. If this is the OS, right? And let's say the API we're using is the socket. My amazing drawing skills here. And I should probably just use a text item, but I like drawing. Need to practice more drawing. System Abstractions. The equivalent of that is network connection. I'll just say net connection for short. Okay, and it's a bidirectional thing. Actually, I should have drawn it kind of like that because it's got two ends, right? Network connection talks to socket. It's going to talk to the user through another library called, well, in this case, it's HTTP. Client. Okay, I'm getting kind of weary drawing, but I need the practice. HTTP client transport, right? And okay, I didn't draw this quite right because I'm running. Oh no, I have some extra space. It looks at the top, the interface. So if we were to draw it in UML, the interface, which is always drawn with a stick and a ball, is HTTP connection. This is not all the classes, it's just to illustrate. So, and on top of that, there are a couple more layers, but I'll just generalize and say, in general, an app which is using HTTP client. You guys laughing at me for my dumb art yet? App that uses HTTP client is gonna, for HTTP, it's using the connection object, which ends up wrapping the network connection class and some system abstractions, which then talks to the socket, right? So I chose yesterday to insert the wrapper essentially here. So put the TLS wrapper here as a decorator. Decorator. Okay, but really, I think where it would have been smarter to do it would have been here. So this would be smarter. Smart. So today I'm going to work to take the TLS decorator, move it from this layer down to this layer. So our app, our HTTP client, is going to still talk directly to the client transport, but somehow we're going to need a way to insert an adapter between the client transport and system abstractions. So what I have in mind to do is when we create this client transport, right now it is hard-coded to always just go straight to network connection. I have it in mind to use dependency injection. So we'll have a dependency on this network connection, this client transport object, and the dependency will be maybe a function that it would call to make a network connection, and maybe by default that function would just create the one from system abstractions directly. But we could have the app change that and insert a different dependency, different function, which instead of just creating one of these, it creates the decorator as well, chains them together, and puts it in here. So that HTTP client transport doesn't need to know about TLS. In fact, you could have other things in this stack, right? And you could even use it with other things that aren't network connections, even. And might be a more convenient way to mock and test the client transport in the first place. And so this class will become more generic and not tied so tightly to system abstractions network connection. But then it's going to be more work for the app, because the app's going to have to decide, okay, if it wants TLS, instead of doing just this extra 4 lines here, where we kind of put it in here and chain it up, it's still going to have to make the decorator, but it's somehow going to have to connect it under the client network transport. Probably something like not just make the client transport and subscribe to diagnostics, but we'll probably have an extra line like transport set connection factory, for example, something like this. And it'd probably go here, and it'll be something. This is just going to be pseudocode. Factory returning network connection directly. And here, it'll be something like factory returning a network connection with a TLS decorator attached. The keyword is factory, because this transport layer ends up making multiple connections. So we can't just make one connection, attach a decorator or not, and give it to the transport or give it to the client. We have to give it a function that's going to make one on demand. And I think part of this restructuring is going to be this TLS decorator right now. If we look at it, and if I look at where it's implemented, it itself is pretty thin. It just has this connect function. All the real meat is in this internal class called connection decorator. So I think what I'm going to end up doing is this outer decorator, which is really thin, is just going to become an implementation of, I already lost where I was, of this factory thing. And then the main class here, connection decorator, is what's returned, this thing that's returned. All right? So anyway, that's my little attempt at art to explain what I was doing. If I had more time today and I was more organized, I would have written this in something like, I don't have Visio, but I'd probably try to do it in PowerPoint. And I probably should eventually, but for now, I'm just going to save this. And by the way, I'm working on trying to get the logo for my company updated. And that's why it's there. So we're going to call this, this is attempt at stunning artwork explaining TLS Decorator design change. All right. That's that for now. So, because yesterday was mostly experimentation, I just wrote the code. I didn't have any unit tests. Today, I think I'm going to do a more professional approach, which will be that I make tests first, because I'm trying to do test-driven development. So let's go first start off by seeing if everything is checked in and stuff. Your own company, yes. I started my own company. Do I need an intern? Right now it's a company of just me and no employees. I actually don't know how to, all the things I need to know to even like go down that road of hiring anybody. But I'll let you know if there becomes an open position, all right? But I thought you had something going. Oh, that's why you put the kappa. I'm sure you're the, what you have going is better than being an intern for poor old me. Okay, so let's run the tests. And yeah, so I don't know if you guys have noticed, but in all my commits, I have this weird domain name. That's the name of my company, Digital Sterling Software LLC. It just started up, and it just consists of me doing consulting if someone wants the work, but really just started up. So yeah, by the time you graduate, maybe I'll be hiring people. We'll see, huh? Get status. Let's see. Just want to make sure everything is clean. Actually, I should not. That -L only checks locally. Without the -L, it's going to go to GitHub to make sure that there aren't any changes I might have pushed on the Linux side of things and forgot about. Just want to make sure we're all up to date and everything is checked in. Okay, the only thing that's been updated is Google Test, but this little hat means I've pinned it to a version that I know works. So I don't need the latest. Let's make some tests first. So we need to put the test somewhere, and I don't think that Decorator really belongs in any of these libraries per se, so I think we need to make a new library. So my general pattern when I make a new library is I go to Visual Studio Code, and I take an old library as close to what I'm making as possible. If not, I'll pick a simple one. I don't know. Let's just pick a simple one. So SHA-1 was pretty simple. So we'll copy SHA-1. And it's not SHA-2. We'll call it TLS. Is it really going to be a decorator? Let me think about that. Really, to decorate something, you have to have a public interface. And right now, network connection is not really an interface. So maybe we'll just call it adapter for now. Actually, let me think about that. Maybe we do, pull up my nifty diagram. Where'd my diagram go? All right. Right now, TLS Decorator decorates a real interface. If I put it down here, I kind of want to have the same thing. A decorator pattern sort of needs an interface to decorate, so maybe network connection needs an interface, and then it remains as a decorator. So that would be 2 steps. We would actually have a decorator, but then in system abstractions, instead of just network connection, which is a concrete class, and you can tell by the fact that it has a struct impl, I like to put an I in front if it's an interface. So let's make an interface. I'll call it I network connection. You can see I kind of follow that same pattern with file and I file. And that's for the same purpose. So file is what you'd expect. It's just a file in the operating system. But in case you have a file-like object which isn't really in the file system, you could have iFile just implemented differently. And I did that when I had string file. String file looks like a file, but it's actually stored in memory as a string. So let's do the same kind of thing for network connection. So the pattern I like to have is to take something that doesn't have an interface and we just extract the interface from it. All right, let's do that. So it's iNetwork connection now, and this is the common interface for objects which handle the exchange of messages between its owner. How about the user? I like to use the name user more broadly. A lot of people think user is the human who's using the computer. I like to think of it as the person or machine or process which made the subject and is the owner. So if a program is making a network connection, the program is the user. And so it's messages between that user and a remote object over a network. It's really just complicated language to say it's a socket or a connection to the outside world. So we will not have types, at least not those types, because those are implementation types. Actually, I think we still need these delegate types because those are used in the interface. No such thing as lifecycle management for an interface. So the rule about interfaces is number one, everything is public in general. So we can just say public. Actually, there's no harm in following my normal pattern. But there's no constructors, no destructors. It used to be that people would always make a virtual destructor, right? And sometimes make it pure virtual. I think you can do that. I can't remember though. But you really don't need to do that anymore when you use well, not that when you use, but when you don't use raw pointers anymore. So if you're using an object through this interface and it's a reference, you're not destroying it anyway. If it's not a reference but a shared pointer, the shared pointer already knows how to destroy it correctly, so you don't need to have a virtual destructor. Hey, the Mater, how's it going? Thank you so much yesterday for your help. You corrected me a bunch of times and I appreciate it. Okay, so yeah, we're not going to have a destructor because I'm using the new scheme of that this interface is either going to be used by reference or through a shared pointer, in which case the destruction is taken care of for us. So we're going to make every method virtual, pure virtual. That's important. Yeah, so right now, the Mater, I'm doing two things. I'm taking my network connection abstraction and I'm making a separation between its interface and implementation a little bit more formal because I plan to, where's my attempt? My attempt at stunning artwork is yesterday, which actually succeeded. And how do I scroll this up? Yesterday I made a decorator for HTTP connection, but I want to kind of use TLS more generically, like with non-HTTP. So a smarter way would be to insert the decorator here. But the decorator pattern needs an interface to decorate, and network connection doesn't have one. So I'm making, where was I? Visual Studio Code. I'm making network connection actually have an interface. So iNetwork connection implemented by network connection. And then I'm having trouble alt-tabbing between things. If I have an iNetwork connection, then the TLS decorator will be an alternative implementation of iNetwork connection, which decorates another iNetwork connection, right? So just in the midst of here of extracting the interface out of network connection. And this is so long, I'm going to wrap it. Actually, there's another reason to wrap it. It's got 2 arguments. Extracting interfaces, you just take all the public methods and you make them pure virtual. That's step 1. Making them pure virtual. Extracting them interfaces. Yeah, it's more formal. Much more formal. Another nice benefit is people using just the interface won't even need to worry about this impl thing being there. Be completely invisible. 0. And this is not pure virtual. This was a helper, right? Actually, this doesn't even belong in the interface at all. The inner code is happier code. Yeah, it helps you guys out because you can maybe read the code a little bit easier. Okay, so there's our interface. And we're all good with that, right? And then we just need to change this now. So, yeah, so it's from one interface to another, so I can include locally. Or connection HPP. I comes after D though. So we just need to update this. To say that it's publicly implementing network connection. I expected it to color that differently. But anyway. So now we're going to remove all the definitions that are inherited. Right, so here, this is my style for saying here are my implementations of interface methods, and I don't repeat the documentation. What I still do though, which is sort of recommended these days, is you still say virtual, but then you add override. So for all these, we remove the redundant documentation because you could just look it up in the base class, and then we mark them as virtual and override. There's that helper though, we'll move the helper. This, I almost deleted this documentation. The helper is still a public method of the implementation. So virtual and override, right? So I should be able to extract this interface with and then test it without very much work. I think that's actually all I need to do, other than I want to list it in my CMake so I can see it in the IDE. network connection, HPP. Make sure that I did not make any CMake. Oh, see, I knew I would make a CMake mistake. That is a header, isn't it? Okay, I'll see you later, the mater. Have a good lunch. I forgot to eat lunch too. I'm hungry already. When I forget to eat lunch before my stream, I end up eating later. Maybe not the best thing. I was going to eat lunch today, but then I decided it would be important for me to learn basic accounting. So I was looking at assets, liability, equity, debits, credits, revenue, expenses, and trying to memorize all the terms. And then I kind of forgot everything about lunch. Alright, so without any other changes, I should be able to build everything, and it should still pass all my tests. because extracting the interface doesn't really affect the users of the concrete class. Except for when that happens. I must have made a mistake. Oh, is it in my... No, it's not in my mocks. Oh, I think I forgot to make some things pure virtual. Oh, and sometimes this doesn't reload like it should. Close Visual Studio, reopen it, and the header file should appear. Here it is. So I probably forgot to make something pure virtual. It was like send message, yeah, see? And the green squiggly is sort of a giveaway. If you hover over it, it says, the definition isn't found. It's like, well, it's because there shouldn't be one. So, a couple other words for this thing. It's a pure virtual base class, also called an abstract interface, or pure abstract interface. Because it should have absolutely no code. It's really just a specification. Specification of some types and some functions that will be in a virtual function table, but no body. That's why there's no CPP file for it. And essentially why we don't need to change any code that uses it either. It's really just bringing out the specification to be a base class. And the code everything is already set up to use is just going straight to the concrete class. But it's going to enable us to define a wrapper or a decorator. Something that looks like a network connection but is really adding stuff like TLS. So I'm going to check that in as our first change. Right, so this plus means I've made this folder, but I haven't added it to my manifest yet. And what did I change in the root? Oh, I just added the directory, okay. Right, so there's no code changes at all. It's really just the definition, or just the declaration of the class. Changed a little, so extract interface iNetwork connection from network connection class. And push that. I think I need to move my mic a little bit. I'm actually not completely happy with my mic setup, but problem is I have it on a, what do you call it, a little clamp holder, but the only good way I can clamp it is above my monitors, and so it's sort of hanging down. And so it's hard to get it positioned right. All right, the decorator stuff. We're going back to Visual Studio Code. Closing all the things first, and I had made this TLS decorator, but I haven't yet renamed stuff, so it's copied from SHA-1. So let's go fix that. TLS Decorator. This is a library which doesn't do that at all. This is a library which decorates the system abstractions iNetwork, or which can be used to decorate objects implementing the iNetwork connection interface. In order to, I guess, tunnel? Not tunnel. In order to add a layer of transport layer security, TLS, to the underlying connection. Let me read this over again and make sure it sounds right. This is a library which can be used to decorate objects implementing system abstractions iNetwork connection interface in order to add a layer of transport layer security to the underlying connections. Okay. Usage. The TLS Decorator class how do we expect it to be used? TLS Decorator class takes another object implementing this interface. I should probably quote that, right? To make it look nice. And what's the, I forget, how do you do the preview? Markdown preview to the side, there we go. Best shortcut to memorize in Visual Studio Code is Control-Shift-P to bring up the command template. Because if you forget a shortcut, but you kind of remember what it's about, so it was preview, or what was it, markup or something? Markdown? Okay, I'll see it this time. Huh, what did I... Is it when it's not open that we can see it? Yeah, so I don't know why it doesn't always show it. Maybe we have to have it closed, but if you have problems with memorizing keyboard shortcuts like I do, you can just remember Control-Shift-P and you type in something that relates to the command you want, and not only does you can run the command, but you can also see the keyboard shortcut for it. So you can try to memorize it by just looking at them. Like, oh yeah, it's Control-KV. Control-KV. Yeah, I think we want the backticks because it at least highlights the word. I think also it makes the font, if the fonts were different between normal text and code, it makes it use the code font. So I should use that for all names in code. So it takes another object. Oh, and I don't need to really wrap this. It's wrapped automatically, right? Forgot about that. Makes another object implementing the interface. And decorates it, passing all data through a TLS layer. I'm trying to think, do I want to mention server versus client, or maybe make that as a change to the README later? Maybe keep it like this for now. The rest of this is boilerplate. License is MIT. Okay, we're going to change this to say TLS Decorator. Everything else looks good, so test CMake. This becomes TLS Decorator tests. And we don't need that. We don't need that. This becomes TLS Decorator. Rename this. I think here I can just replace this part of it. I still love this multi-cursor thing. It's awesome. Okay, we don't know what the tests are going to be yet. But let's think of one. So what are we going to test with the decorator? How about that? Well, one thing at a time. What are some things that it will do? What are some things that it does now? It's essentially this connection decorator is going to become TLS Decorator. And the thing previously known as TLS Decorator is just going to become a factory in an upper layer integration, like probably in Rover, we'll do this stuff. So what are the individual things this does? Is it easy to test the worker thread, the side effect of the worker thread stopping the destructor? Maybe not. This has no visible effect. This does, though. So you remote connection break forwarded when no secure data buffered. Let's just enumerate the different tests based off of what we kind of already established are what we want the class to do. So this reflects this condition here that we can observe directly, because this broken delegate, our test framework will implement this. So we can just check to see if it's called or not, based on if we put in some secure data. Connect. I guess we'll verify that connect configures and opens a TLS connection with callbacks, which means I think I'm going to end up mocking the actual TLS library. So connect procedure, since it's several things, right? And what else? How about that peer address and ID are forwarded? Peer address and port are forwarded. And then, actually, it's not this class I need to worry about. It's the iNetwork connection class. Right. So that's another benefit of using iNetwork connection as our interface, because it'll let us clean up our diagnostics and have a real diagnostics subscription. So let me build that in. Diagnostics subscription. Test that. That's the connect procedure. Okay, it's going to be a little different, because right here the connect is given the delegates directly, and here the connect and process are different calls. Well, probably in connect it will just store the address and port and not actually connect until we do process. That's what I'm thinking of doing. Or really, connect should forward the actual connect. And process should do all the TLS stuff, right? What happened to... Oh, I was in VS Code. Yeah, that's right. Okay, so... This has a peer address and port. We expect those to be forwarded. So this thing about connect and process. We'll say that connect forwarded without starting TLS. And then we'll say that we'll expect that process starts TLS. And connection processing as well. We're going to end up mocking the connection, and we're going to be mocking TLS as well. Okay, what else besides connect and process in the addresses? Is connected. I think that's also expected to be forwarded. Is connected, forwarded. Bound address and port are connected. Okay, send message. What do we expect send message to do? I expect send message queues data with TLS right. That's what I expect. And close. Actually, here we want to kind of say, because we have this flag where we'll attempt to complete data transmission. So I think what I want to say is close, a clean close. Processes all queued TLS. Is it really queued? Yeah, because it has a worker thread, doesn't it? So clean close processes all queued. It's asynchronous anyway. Clean close processes all queued TLS writes before actually closing. And then unclean close forwarded. Forwarded. We want it to be sort of just break the connection. And then do we have something for receive? I don't think we do yet. We can look at the decorator and how it handles that. That was up here, right? So we expect it to be queued and then asynchronously processed by our worker, right? And the way the worker works is there's a TLS read, which ends up calling the callback, the read callback, to pull in the secure data, and we expect it to come out of TLS read as decrypted data. Right? And then that's delivered. So we'll say maybe near send, kind of like a send. I lost my clipboard already. I wanted that to be in the clipboard. That's my template. Okay. So secure data received results in decrypted data delivered, right? And how does it handle incoming breaks? Oh, we already had a condition for that, right? Remote connection break forwarded when no secure data buffered. Let me move that down here. I wanted to move it data received and connection broken to be kind of close to each other. Well, if you guys think of anything I'm not testing, like use cases of this wrapper I'm not testing, let me know. Otherwise, I think I'm going to see that these are all the tests that we're going to want. And for now, let's trim the include list to just the bare minimum. Should I make a fixture? Let's make a fixture. So we'll pick something that has a fixture. Something simple that has a fixture. One of these maybe. That doesn't have a fixture. I guess those were too simple. Does WebSockets have a fixture? It has a mock connection. Okay, it does have a fixture. Let's copy it. For now, it will just make it a simple fixture. This is the test fixture for these tests providing common setup and turn off for each test. That's exactly what it does. And the unit under test is one of these guys. So we'll call it Decorator, because I'm going to have a mock called TLS later. Yeah, let's have capturing of diagnostic messages. That sounds like a good idea. So we'll need string and we'll need vector. And what else? Oh, we need the diagnostic sender, don't we? All right, and we don't need this. This is old. It's Decorator. Size T. That's in standard def. So you might think I'm just putting back all the includes I had before, but I deleted them at first and just adding the ones I know I need just to keep it clean. So I don't end up including things I don't need just simply because of copy pasta. Okay, do we want to do this kind of thing? That was important for testing moving the thing, right? Until we need it, let's leave that out. This just undoes that. And we'll change all. How do I replace, what is it, select? It's not all occurrences of find. I guess it is. But I need to, I want my find to be case sensitive. And then, is that how I do it? And then L? Yeah, there we go. So I want it to be test F. And let's turn off the case sensitivity thing. Right. So there's our boilerplate for our tests. Actual code, TLS Decorator, CVP. This module contains the implementation of that is a class, not a functions. The copyright cannot claim back to 2016. All we know is we need that at first, and we don't have that. We actually don't have anything in here yet. This is TLS Decorator. You might be wondering why I say it twice. That is because this library just has one class. And when that happens, the class, I like to call it as a principal class. It's like the main class. And if it's a small library, usually the library is just really a thin veneer or shell to build a single class. But they're still separate things. The library is a separate thing from the class. So even though their names are the same, I want to list it twice because my general convention is it's library name, class name, and then HTTP. Same thing for the namespaces. The namespace, let me fix this. If I can type, the namespace name is the same as the library name, but the class name is separate. It's the class within the namespace. So I'm going to copy just the shell of something. So I'll copy this. Actually, let's just copy the whole thing. The whole thing to start with, right? All of that. And put it here. And we're just going to rename it to be TLS Decorator. This is a decorator for, in this case, it's not this class, but System Abstractions network connection, which passes all data through a TLS layer. So all this code won't build, but We at least need to have it. We can fix this part though. Obviously it won't build, but at least I have the position for the class to start with. And we're going to be moving the bodies of the functions to here. But right now, they're the wrong functions anyway, so I think I'll just leave it for the moment. I just need to connect this up, so a couple things. In our main CMake lists, we need to add it. Add subdirectory TLS Decorator. All right, and then what's next? What do I want to do next? I guess establish the repo. Git init. And then I'm going to just cheat and cat my main manifest so I can just look at the, because it's going to be the same URL but with TLS Decorator there. So it's going to be git remote add origin, git at github.com, my handle, TLS decorator.git. It already exists. Oh, wait a minute. Oh, yeah, I copied everything from SHA-1, including the .git folder. By the way, this is a very dangerous command to do unless you're extra sure what you're doing. Git init now, it's a fresh repository, not copied from SHA-1. Okay, so I'm not yet ready to do the rest. The rest would be to add it back to that manifest. I don't want to do that, and I don't want to really do that until I actually make a commit here, and I don't want to make a commit until it builds. Let's do the building thing first. We bring it in to CMake, into our solution, and hope that this time Visual Studio detects it correctly. Good. And we'll see it show up here and in the tests as well. There. So we can look at our tests and... Did I not spell this correctly? Oh, I probably did not pull that in as a dependency. Okay, it should be a dependency of TLS. That's the problem. TLS Decorator, that is. Right, it doesn't have any dependencies listed. Let's copy from this guy. So there. So for sure all I know is we will need that. Now we should get it. Almost. Yeah, so this won't compile until we fix up the class. For that, yes, we do need string extensions, and really it would be appropriate to also have the test directly depend on system abstractions because of this usage. We don't want to piggyback on the fact that TLS Decorator depends on system abstractions in order to get this. We want to say, yeah, we need it directly too because we're going directly there. All right. Okay, next I'm going to fix the Decorator class so it at least compiles, even though it won't work. But before that, I need to take a minute break. So I will be right back in a minute or less, hopefully. All right, I'll be right back. I'm back. So some random thoughts I had while I was on my little short break there was, does anyone on Twitch stream just like doing random stuff on their computer, like browsing websites? And if so, do people actually like to watch that? Like stream of consciousness, or I guess it would be philosophical ranting streams? And if so, is there a good example streamer? Because I kind of want to see if anyone does that. Asking for a friend, you know? Yeah, anyway. We are going to overhaul this class now, at least get it to compile. So let's start by moving the destructor. I do this correctly in the correct file? No, I'm not. Not that file, so TLS Decorator CPP. Here we go. And then we can do that. All right. Constructor, same deal. So the decrypted buffer size moves as well. Okay, that was, let's see if Visual Studio can show me. Ah, look, I was smart. It's like, I've seen that before in that other CPP file. Maybe that's what you want. In this case, it was correct. Okay, size t is technically defined in standard def.h. And we're going to be moving that, but for now, let's include the correct header to get that. Okay, that probably is because I gave it a body here, so no body. Error type, yeah, see, it's until I get rid of these errors in the header file, it's going to give me trouble. Actually, I didn't notice that before. I forgot to have a space there. Normally my eyes would see that and it kind of would scream at me saying, oh, you forgot a space. For some reason it didn't. Oh, need a space, like that. I'm fairly pedantic when it comes to that kind of thing. People get annoyed, at least when at my old job, people get really annoyed when I would point out stupid typos like that. They'd be like, come on, get to the real code review. I don't care about the typos. Yeah, mostly this first step is going to be moving code from the header to the implementation file. A more formal way for a public class, what we have to do, right? Yeah, this is going to be broken because the delegates aren't named the same and they don't have the same semantics either. All right. And then this is all different. But I don't want to remove the code per se. We just need the code to live somewhere else. So what I'm going to do, I'm going to take all this and cut it out and paste it here, but I'm going to put it all in a big comment for now. We're gonna draw from that. It's Alt E VM. We're gonna draw from that to fill in the real implementation. Okay, worker. Let's move worker. Worker goes here. Although that's a private method. We're going to be moving that again very soon. Because we're going to introduce an impl class to put all the private stuff in it. But for starters, we'll keep it out. Okay, at least for the short term, I need to have it include, okay, I could have typed that. Temporarily, we'll need to do that, which means that in the CMake, I have to also have the same stuff. So that was here, and it was TLS, SSL, and crypto. Okay. Okay, what happened to my header file in the editor was lost. Okay, here we're back. Okay, condition variable, vector, standard integer, condition variable, maybe text, thread, vector. I already had vector. Memory for a shared pointer. And I guess it's time to fix this. So let's actually let me pull in the interface. Whoa. Why did it tell me that? Anyway, let's pull in the interface. Oh, I have a better idea. We'll go to another implementation and we'll just simply copy paste this junk. Since that goes verbatim, actually including the little header thing, goes verbatim here. Oh, wait a minute. How about just this part? Goes here. Okay. Right, so scope this correctly. Cool. Now we'll put bodies for these. So that goes after connect. Collapse that for now. All right. Okay, in all of these, strike virtual out. Actually, a faster way would be to select that, hit search and replace virtual space and replace it with empty string. And then while we're at it, we will replace override bracket with override space open brace. Can I do this? I don't know if that'll work. Nope. Maybe if you do regular expressions. Ah, look at that. That's not quite what I wanted. I wanted extra space here. Whoops. I lost what I typed here. It was override space bracket new line, 4 spaces, empty bracket new line, I think. Oh, not within current document. Let me copy that so I don't lose it. Okay. There we go. Too many new lines. So undo. Redo. There we go. And I need to put this TLS decorator in front of everything. Can't think of a clever way to search replace that guy, so I'm just gonna go through it. Oh, shoot. We need to strike override, don't we? Override. Actually, with the space in front, strike that. Okay. So then let's just do a null, because we just want to do the minimum to get it to build for now. Just return the default values for everything. Okay, so this is not the correct type anymore. It's message received delegate. And I think we don't need to do this because it's already within the scope since we're deriving from that class. Do we need to say that though? Is that because deriving from that you get it? I'm not comfortable with that. I'm going to leave it like that. I know this will be within the scope of this because we're deriving a class. We're deriving from the class in which it was defined, so or declared. So I think that's okay, but I want to keep that prefix. Same thing with these. Actually, didn't it give me an error before when I did that? Yeah, so you don't get everything in the namespace. You just get the ones that were declared in the base class and maybe the base class name itself. Right, so this message received delegate goes here. Oh, and in my documentation, did I mention the word upper layer? It's lower layer, isn't it? I had that backwards pretty much everywhere. Oh, and where I say the word client, I want to try to remove the fact that it's a client. This is going to be tricky though. Maybe what we'll do is we'll have a connect client and we'll have a connect server. Well, no, connect server is this, right? Connect to server. Yeah, I think connect to client will have some other arguments, right? Instead of a server name, it'll probably be a certificate of some kind. And perhaps a client name. I don't know what TLS wants. And we're going to say that this establishes a TLS connection as a client connecting to a server and sets of the decorators that, yes. All right, so let's update the name of this method. And then that type is, oh, and the name. That name in a bunch of places. Oh, that was a copy pasta error, wasn't it? Make sure our names are consistent. Okay. I'm not going to change that to data. I'm okay with it just being data there, but I want when it says received, message received, I want it to match this message received. All right. Now as for this actual code, I don't think, yeah, so we need to search for upper and turn it into lower. data, let's just do this. Search replace data received as message received. Min needs algorithm. Send data is send message. Mutex. Oh, I forgot to scope it into the class. That would be why. Break is like close instead of break, right? Close. Okay, now does this compile? Okay, yeah, we can't change or even respecify the default argument in the implementation. This compiles is totally not going to work though, but I just want to make sure that everything compiles. Do all the things compile now? No. Oh, right, because we did not mock TLS. Interesting. Interesting. So TLS itself seems to depend on, in Windows it would be WinSock. Interesting. I would expect that they would have that dependency specified. So maybe they did and I just didn't see it. They have a problem in their CMake where they only specify their dependencies if you're building a shared lib. Oh, they do have that. We need to do the same thing. We need to do that in our decorator. This public. Actually, you know what? In there, instead of doing that, I have something else I prefer to do. I think it's just a preference thing, but I prefer to do it with a pragma. So, oh, hold on, wait a minute. If I do it with a pragma, then I have to have an if-def win32. Oh, but I need it here anyway. Actually, maybe I'll leave it the way it is, because that kind of matches what they're doing in their CMake. Try that out. Error. I forgot something. Oh, yeah. That's not how you do it. You do this. End if. Syntax is different. It's 1:24 p.m. Build. Cool. So everything builds, and I can actually run it. I don't know what it'll do, but I can say TLS Decorator test debug TLS Decorator tests. And it just fails everything with an exception in our teardown. Yeah, because we're calling an unsubscribed delegate, which is null. That's fine. So one thing at a time. So to get to the subscription stuff, I'll just copy what we did in network connection itself. Actually, it's the cross-platform part. We just did this. Oh, this impl reminds me. Before I do that, I need to do the second step of separating the interface from the implementation. So I have the header separated from the code, but I have not separated the private methods and properties yet. So to do that, we take all of them basically. out of the header and put them into the CPP here as struct TLS Decorator impl. Paste that in there. Without that. All right. That's step one. And this becomes properties. And this just becomes methods. And then all of this gets replaced with a bit of boilerplate. So I can copy it from another class. Network. How about file? No, not this much. The simpler boilerplate that doesn't have OS differences. How about WebSockets? Since I kind of liked WebSockets. I liked working on that one. That was a fun class. There's our standard boilerplate. We define a structure. We define it here because if we were to do this instead, it turns out it will consider the impl to be in the global namespace. I don't know why, but it just does. If instead you forward, this is like a forward declare of the structure, and then you just refer to it here, then now impl will be within the namespace of this class. So it lets me do something like this. So there's a different impl for every class, rather than having the global namespace polluted by a word impl. Before, what I would do is I would just repeat the class name. And you can do that too. I just think it's unnecessary namespace pollution to have both TLS Decorator and TLS Decorator impl, two names being in the global namespace, where if I do it this way, it's just TLS Decorator, one name in the global namespace. And impl is sort of hidden within the class. Actually, not the global namespace, but the library's namespace. So yeah, we do that. And a couple things change. So we need to have the destructor make the thing. Like that. Why did it not oh, that's just a temporary thing. Okay, so that's step one. Step two, actually 3 steps. Step 2 would be, I'm going to remove the underscores from all of these guys. So that, oops, that wasn't good. Let's try that first, and then worker. Next, broken delegate. And next, TLS simple. The reason I'm stripping off the underscores is they're already inside an implementation structure, so they're already sort of designated as private. With respect to the external world, they're private. Whereas before, they were declared right in the public API, so I used the underscore in the public API to designate something as private. Since they're already hidden now inside this impl structure, they're already hidden, so we don't need to it's be redundant to have another underscore. That's at least my justification. It is sort of a pain, though. I have to do a bunch of these search replaces. I was thinking about that yesterday, too, when I was writing this code. I'm like, I have to go back and do a bunch of renames whenever I formalize this class. But it's something I can almost do without thinking, which gives me the opportunity to ramble. Can ramble while I'm doing it. Okay, I'm almost done though. Now wherever we have a public method call access something in the implementation, we have to do implementation underscore arrow. And if that gets a little bit too annoying, we can always refactor that to be inside the impl structure itself, and then we remove the impl underscore arrow. But I don't think it's too bad. You just go through and paste that in front of every reference to a implementation variable. Also, it kind of reinforces the fact that it is in our state. So if you see an impl arrow, it means it's definitely part of our object state, as opposed to maybe a parameter or a local variable. Yeah, this. Yeah, double indirection. That's the other cost of using the pimple pattern, is that it takes 2 steps of indirection to get from the public API to the implementation state. I could do like a const auto impl equals self arrow impl and then cut out all this redundant lookups or dereferences. I could do that if I wanted. Kind of don't feel like it though. Just leave it the way it is. This changes a little bit. This becomes impl, and this becomes impl get. And this moves. So we'll take this whole body here, completely out, and paste it here. And some people have the style where they declare worker and then put its body elsewhere. I don't really have a problem with putting it in line, because you can always do that if it gets in the way. All right, so we're in pretty good shape here. It's not going to work, but we've at least separated interface from implementation. Oh, I need to go back and clean up the headers we include here. So the only headers now we'll really need are the ones that the public API requires. So vector, standard integers, network connection, string. But we do not need condition variable. It's essentially moved to the CPP file. We won't need mutex. And we won't need TLS. And we won't need thread. Right? Still need vector, still need a network connection. Still need string, standard integers, and memories, because we're using oh, we can use that at unique, can't we? That's preferred when there's only going to be one owner or user. All right, anything else? String, yes, yes. Vector. Okay, we're good. Let's try building that. Okay. This will still crash, but that's fine. Next step. I think it's where we're going to relocate the code. So get peer address goes there. Impl. So that's taken care of. Peer ID. There isn't an equivalent peer ID, but we know what we can do with peer port. We simply forward it. These ones we do not need to worry about, correct? Yeah, so yeah, that's actually one benefit for switching to implementing network connection instead of HTTP connection, because HTTP connection has this design flaw where there's like, depending on the implementation, there's two ways to set the delegates, and you're not supposed to use the incorrect way. So we get away from that. Okay, then send data, the closest equivalent to that would be the send message. That's Alt E, V, and then E is to remove comments, and M is to add comments. It's M, E, V, E. So that's something I've memorized. Okay, message. Let's name that data. Actually, let's make it message. Impl arrows where we need them. Message instead of data. All right, and then close is the equivalent of break. And say close. Okay, now to fix that crash, I was planning to just copy from some other code which does exactly what I want. So this implies I need one of these guys, which we can get, and paste it where we want it in our state here. Let's put it at the top. And that is in its own header. System Abstractions Diagnostic Sender. Needs to be properly scoped in the namespace. There we go. So that should solve the crashes, right? Oh, okay. Impl is deleted. Oh, I haven't mentioned that this stream. Whenever you see that overlay, that's because I'm muting the mic to talk to someone. Or if the dog is barking. I initially set up that overlay because people would come to the door, or a mailman would come by and the dog would bark, and I didn't want it to annoy you guys. Nowadays it's mostly it's because someone behind me wants to say something or ask me a question. So you'll see me occasionally mute the mic for that. All right. I know why I'm getting that error. Although I'm interested to see, oh, I think it's because this guy has, yeah. Right, so we're using Diagnostic Sender. Diagnostic Sender has an explicit constructor that it wants to know what sender string to use. Let me just double check that. I think it's HTTP network transport. Let's see if it does what I think it should do. Okay, yeah, so we had to have a constructor for the impl itself. So here are impl. And we just do it. I don't know why it's made shared. Why did we do that? Why did I have a shared pointer? Oh, that might have been to decouple it so that diagnostic messages don't end up going through a sender that's been destroyed. When did I make that change, though? If I look at that in Visual Studio Code, it'll give me a git lens on it. That was HTTP. No. HTTP network transport client. There. So what does git lens have to say about this line? just added it? Maybe I copied it from here. I seem to remember there was some reason why I had to make the diagnostic delegate shared. Ah, here we go. Fixed lifecycle bug. Forward all diagnostics from connections created. Oh, is it because they really are shared? Yeah, it has to do with the dynamics of how this class interacted with this class, I believe. Trying to see how that worked. Maybe not that one. Maybe it was something else. I'm curious now. I'm going to trace this down and see what it was. Oh, okay. It was hidden within a delegate. Yeah, so it was being shared with the adapters created for new connections. So I don't think I really need to do that in my TLS decorator. I can just instead of having a shared pointer, it's just that. And we'll call it TLS decorator. All right, so will that build? Cool. So it probably won't crash now, but it'll still fail a bunch of things. Actually, no, it might pass because we don't actually do anything in the tests. Although we're getting the Atom nuke. That's an Atom 13531 joke. An emote that he added recently. Okay, we can remove that now. That was I really only put that in there temporarily, and that was just to make sure my destructor was being called. So let's remove that joke. Okay, so everything's passing because we have no requirements. Someone else saying bye. Okay. Wrong class. Correct class. Okay. Yeah, we need to do a little bit of a change, I think. I think we don't want this connect to server, do we? Because we already have connect and process. I don't want them to really overlap in functionality, which there's obviously an overlap there. I'm thinking what I want is you'll first set up the adapter, and then you'll call, first set up the adapter, and when you're setting up the adapter, you'll give the lower layer and the server name. So basically, strike this part, and it's not really connect, it's really configure. So you'll first configure it, then you probably give it to an upper level app or something, and the app will call connect and process. And connect will be passed through, but process is going to configure TLS and then call process of the underlying socket. I think that's what we want to do. So this secure message received. This is actually going to be handled by this message received delegate, isn't it? Oh, these were really not supposed to be public anyway, were they? Actually, nothing's calling them. Where were they called before? Let me look at the old version in Rover. Oh, it was secure data received, I think. Oh, right. So it was, yeah. So this is really the responsibility. Let me close this guy again. This is really the responsibility of our user. We have to get it into our receive buffer, though. That's our part, though. Oh, no. I take that back. This isn't the user's responsibility. This is the delegate that we need to insert between the two delegates. So I think what we want to end up doing is when process is called, we're going to call process of the underlying connection, and we're going to be passing in these. So these really are implementation only. And we will move them. So they belong up here. And right there. This is call when, so yep, that's exactly what I want. And we'll move the bodies. Hide the bodies, right? There's lots of opportunities when you're doing programming to like make jokes about non-programming things. Like, what was it? Someone was making jokes about the kill command. Kill all the children or something like that. If you're not a programmer, you're like, what is he talking about? Kill the children. But in programming, it's perfectly legitimate in Unix to kill all the child processes. It doesn't mean anything bad. It just means terminate the programs that were started by an outer program. Okay, yeah. So what I was basically doing is a function, a method that used to be public is now private. So it gets moved into the impl, and all the impl dereferences go away. The code should remain intact. And then I can just drop it. Okay, so I had updated this, so it's now called configure. And we're missing these two delegates. Let's change the documentation. So it doesn't establish it. This method sets up a decorator to insert a TLS layer and configure it for client mode, connecting to a server. So there's the lower level connection to decorate. And then we don't need to do that. There's the server name. And I don't know if we still can fail, actually. Because this doesn't happen until process. All that we want to do here is save the lower layer. And we're going to want to save the server because we need the server later when we do this connect with callbacks. Yeah. So I don't think this is going to fail. It's just configure. And that also means that we're going to want to save the server name for later reuse or later use. So it needs to be something that we can configure near a lower layer, I guess. And it's eventually this decorator is going to work for servers as well. So what we'll say, when configured to operate TLS in client mode. This is the name of the server with which to connect as a TLS client. And then standard string server name. So then configure can just save it. Server name. Actually, I see a problem here, which Visual Studio didn't help me detect. I actually want to store it in our state, not do a self-assignment. Alright, I don't think we need to do this. Actually, maybe we do. If someone calls... Why is this an error? Oh, because of the return value. If someone calls configure and then calls it again, I think we want it to be a no-op. We do it if the worker thread is running. Basically, if we're already processing, we don't want them to call configure and change the lower layer. So we'll keep that code, but all of this stuff should move. This stuff needs to move. I think it's going to move to process. Like that. And then because this was in a different method and we saved it, we'll pick it back out there. Okay. Yeah, I think connect should just forward it. That's the low level connection, right? So lower layer connect. Process, we're not done yet. We actually need to save it. Or do we end up just do we end up using them? No, we use them from a completely different context, so we need to save them. So yeah, I need to go copy the documentation for it. We need to copy them. Because we need to store them in our implementation. Actually, why am I putting methods first? Oh, because in the public API, I list methods first and then properties if they're private. But it's actually, I like to have it the other way around. Oh, I already have this here. Okay, we already have that. Yeah, so I'm going to put the properties first. It's just a preference thing. For public things, I like to list properties first and then methods. Like that. So properties of the structure and then the methods of the structure. And then what was it called? Process? Yeah, okay, so that already worked. So let's see if this is doing what I expect it to be doing. I don't want to get too far into this before I write the unit test, though. I kind of just wanted to reorganize it minimally. And maybe we're done with that. Maybe we go and write the test next. Okay, so... Oh, wait a minute. I said earlier I wanted to mock libTLS itself, right? That means I need to have some sort of dependency injection. Actually, you know, an easy thing to do, since libTLS is a C API, we can actually do it as we can do the dependency injection at the linker level. So what I'm saying is TLS Decorator shouldn't be tightly coupled to TLS libTLS as a dependency. It should let the program inject that as whatever it wants for TLS. And I think the easiest way to do that is to go to TLS decorator itself, and you see how I'm specifying dependencies here? If I simply remove that, oh wait a minute, that won't work. Hold on. It'll almost work. The problem is, I'll show you the problem. Problem is it won't even compile now. Because we don't know where, we won't be able to find the headers. Right? I'm wondering if I can do a trick where at compile, we can depend on it at compile time, but not link time. I guess we can do it with this. It's just, actually, yeah, target includes, it is public. Let's make a list here. I'm thinking maybe I can do it with a generator. I just need to look at, my manual to see. How do you use generators again? I always forget. CSC make. Generator expressions. I think this is it. Target properties include directories. But I need to do it with a certain, it's not target property. Oh, it's target property with target comma. So if I say something like, I think this would work. Target property TLS comma include directories. Let's see if CMake lets me do that. Oh, cool. So that'll work. That will no longer link. It doesn't even compile. Why doesn't it compile? Strain nlen inconsistent DLL linkage. Really? Previous declarations here. Oh, this is in the crypto library. Yeah, there are some macros, I guess, that are declared. They're declared, yeah, so how do I get those? Let's look at the CMake file for TLS. I don't have it open. So librsSL, TLS CMake. Oh, actually, it's probably in the global librsSL CMake list. They probably did this. Ah. Okay, that's gonna be a little bit tricky. Can I get the target definitions from a generator? Add definitions. Let's see if that's available as a property. Oh, hi, the Mater, welcome back. I'm just trying to set up my decorator so as not to directly depend on librsSL, but allow you to compile with it. So I'm trying to set up the test framework so I can mock the actual TLS library with a mock, but then still allow you to include the headers from the real librsSL. It would be something like defines? Nope. Definitions? Compile definitions. Okay, maybe that's what we want. I can try that. I might get more than I want though. Let's try it. So it would be, hold on. In our CMake, it would be target compile definitions, this public, and then the same kind of thing, but it would be, what did I see in the manual? It was called compile definitions. I have no idea if this will work. If it does, I'll be thrilled. Let's maybe expect it doesn't work and be happy if it does. No. Okay, now it's slightly different. It thinks I am redefining something. Inline is redefined, really? Whoa. Something tried to macroize a keyword? Okay, yeah, I really confused it. Interesting. So we're not even looking at the correct project. It was when it was compiling TLS Decorator tests. Interesting. It doesn't think it should actually get into that if. That's why it's gray. Oh well, I guess it doesn't. I guess it didn't work. Wonder if I could if I can just brute force it. So instead of doing that, what happens if I just repeat all this nonsense? I call it nonsense because I think it's sort of, it's like looking for non-standard things. Like, why are you even depending on non-standard things? Never did like this kind of stuff. Have stuff. Okay, I'm just gonna give up. So to give up, we're gonna undo all this stuff, and we will go back to depending directly on TLS. We'll just have to make a shim. Yeah, other people see libraries. This is in this case, it's LibreSSL. So the problem is that they are adding definitions, which means that in order to even compile with their headers, I need to depend on their library with target link libraries. So I was trying to remove that. If I do a redo, can I do a redo? Can't do a redo. I tried to remove that there and instead add to my include path the TLS libraries include path, and it finds the header, but it's like, well, you don't have the same defines. And that's because you only get these defines if you depend on it, I think, at link time. Actually, what happens if I just depend on it? I have a project dependency. It probably still won't pull in the defines. This will pull in the defines though. It's just now it's going to depend on the actual implementation. So in order to test it, I need to have a shim. We had this idea of a shim that we used before with testing the clipboard. So I think we'll just do that again. The idea was in the clipboard, there is an interface, which is really a shim layer, because by default what it does is it's just forwarding every call. And that's what we'll do. We'll have the default shim for TLS, we'll just call the real TLS functions. But then what the test does is it inserts its own substitute. So like clipboard tests here, has a substitute shim, which doesn't go to the real clipboard. It goes to something else that the test can inspect the side effects of it. Because it's how do you test a wrapper for the clipboard if you don't have a real clipboard? The answer is you have to shim the clipboard, and then the test puts in a mock at the shim layer. So let's shim it. It builds now, right? Back to building. No. Okay, I really screwed something up then. Let me see what my changes were. Nothing there. Okay, it's all in TLS Decorator. So TLS Decorator. Let's do a rebuild all. Thinking it has something to do with a cache. Your other streamers are asleep. Are they all in Europe or Asia? They're streaming, but they're asleep? That's against the Twitch terms of service, isn't it? Okay, we got it to build this time. Okay, so you're not saying they're literally asleep, are they? Or are they just... I'm trying to think. They're making you sleep? They're that boring? Okay, so we need to make a shim. So we need to declare the shim. Literally asleep, really. Resident sleeper, right? Okay, this is used to shim the actual... Am I using the term correctly? Oh, I closed my web browser. Let's open it again. Okay, define shim. Shim. Shim computing. A small library transparently intercepts. Okay, so like it's the actual thing, not the interface. So we should say this is the interface for the shim to place between TLS Decorator and the actual TLS library. It's by default the shim forwards all calls to the real TLS library. During testing, the test framework replaces the shim with an implementation used to test without using a real TLS implementation. A long-worded expression, but that's okay. So class TLS shim, have it make it an I, and it's going to be pure virtual. So public virtual. We basically need to have a method for every call to libTLS that we have. So let's look at them all. So it's going to be all the TLS underscores, right? TLS write. Let's see how that's declared. I'm just going to copy it literally. CPP is what I want. Okay. Next. TLS read. declaration equals 0. Actually, might not be a whole lot. Okay, we need TLS error. Okay. So what about Adam? Isn't he still streaming? What's Adam doing right now? Adam's not asleep. You know Adam, don't you? Looks like he's back from lunch. Adam and Raimu, the only two not asleep. Okay, config new. We need that. Alright, next. TLS. Okay, I can see we're going to need config free, close, and free. So let's grab all three of those. Free. Close. Oh, they're away while stream is going? I know, what's the etiquette for that? Is it okay to be away? It's probably okay to be away for a few minutes, right? But one thing I was watching one streamer yesterday, and they did a polite thing, which is when they were about to go on break, they typed in chat something like, I'll be back at, and then they typed a time which was like 5 minutes in the future, so that if you came in and you're like, oh, when did they go on break? Are they coming back soon? You can look at the chat and they would be like, oh, okay, they're coming back in a minute. So I should probably do that when I take my minute-long breaks as well. But yeah, what's the general etiquette? How long is it okay to be away for? Like, I guess if you're going away for lunch and you have something like what Adam does, that's probably okay, right? Because you have something obviously interactive still that you can still chat and you can still see like lunch notices. I'm just curious. Okay, what else would we see? Oh, this one. Okay, I don't know if I'll need this. Yeah, we'll put it in. Looks like they're together anyway. You could put in a be back later thing, then whatever. I guess what they don't want to do is stop streaming and the people say, oh, well, he must be done for the day. It also breaks up the VOD, right? I know if I did that, I would end up with like 2 videos. And I don't actually know how you do it, but how would you glue them back together without doing it in your own video editor? I don't even know how to do that. Everyone's going on break simultaneously though, huh? It's not even like lunchtime unless you're in Hawaii now. Why is everyone on break right now? Come on, people. Okay, configure. Do I already have this one? I think I'm near the end though. I'm gonna resort these into something that makes more sense. Right now I'm just collecting. I'm the collector. Collect, connect, callbacks. This is a beefy one, right? So beefy they put it into 2 lines. I'm not even really gonna bother to reformat it. Okay, good. So let's sort them into some kind of sane arrangement. Config new, and let's put the free with it. And we'll put the config stuff near. Now let's put this one first. TLS client. Did I forget TLS client? Yeah, I did. I totally forgot it. I want to put that next. And close maybe. Close and free last. Error, I guess we can put error anywhere. Let's put error at the top. Read, I think feels better to be before write. Connect before we try to read and write. All right, so there's our shim. I think I'm not going to bother writing documentation because this is not even my interface. We'll say in the note, whoa, sorry about that. Note, the methods of this interface match one-to-one with the functions from libTLS, which this library, which are actually needed by TLS Decorator. The methods of this interface match one-to-one with the functions from TLS, which are actually needed by the TLS Decorator. Please look at the documentation for libTLS for descriptions of any particular method. Okay. There we go. So we're going to have a default implementation and we need to have a way to hook it. So I'm going to look and see, what did I do for the clipboard? I want to do the same exact thing. Clippy board. Okay, so I had an extern declared global pointer. Sounds good to me, so we do this. We say external TLS shim pointer selected TLS shim. I didn't even bother to document it. Horrible. I was very lazy there. Well, we'll not be lazy this time. We'll say this is available for users to change the shim used to connect TLS Decorator class with the TLS implementation. The default value is a global instance of a class which simply forwards each method to the actual libTLS implementation. This isn't capitalized, is it? All right, and I'm guessing it's in the CPP file where they actually do the implementation of that. Or actually, there's two things. You have to provide the storage for it. Okay, here's the storage, and then this looks like the implementation. Oh, wait. Okay, this allows... Oh, no. Hold on. Oh, I don't quite understand this. These are virtual. Oh, is it that you overwrite it? Okay, maybe we'll do that instead. Instead of having it pure virtual, they just make them overwritable. And so you would derive a class and override what you care about. I guess that makes sense. Then you can have like just shim a few things if you wanted. Okay, so yeah, let's do the same thing. So instead of it being pure virtual, so space equals 0 becomes nothing. Instead, they just have a default. And we'll just say this is the base class for the shim. By default, the base class, let's say the default, the base class forwards all with, replaces the shim with a derived class used to test without using the real TLS implementation. I suppose that means we always link with the TLS library, right? Because we have no choice. But we just never call it. The derived class sort of redirects all the calls. All right, and then in the implementation, we'll do the same kind of thing. So they have a derived class. So this is no longer that. No, the test will have a derived class. We will have the base class here. So all of these methods we will implement. Oh, right. This was to give the global instance. So TLS shim base. And then where do we declare the okay, the shim is within the TLS decorator namespace, so we provide storage here. Not there. Here. TLS shim selected TLS shim. It was this, right? Equals the address of TLS shim base. Or should we say, okay, this, I need to scope it. This, wait a minute, I'm not doing this right, am I? Oh, no, I am. This is because we actually need to have something pointing to it. So this is a singleton providing something for the shim, the global shim, TLS shim pointer to point to by default. And here we provide storage for the TLS shim pointer. All right. And then we still need to actually oh, forgot that. We still need to actually implement these. Singleton, yeah. Sorry. Singleton it is. We'll do this in the correct order. So before the storage, we'll implement the methods. So here. All right, so virtual goes away. We put TLS shim in front. Oh, what error? What error? Oh, it's probably because I did that, right? Yeah, okay, so we're good. Just go through. Oh, no, that's not right. It needs 2 colons. Just put it in all the places. These are going to be dead simple, though. They're going to be all one-liners. Just some will return and some won't. We will just return from the global TLS error, UTX, like that. Oh, I thought by the emote that you're shocked that I was using a singleton, or you're disappointed. The not like this is supposed to be shock or disappointment, right? Or am I not understanding that right? Protocols. I don't like that they have underscore in front of all of their parameters. Why is it not like that? Oh, that was a temporary thing. IntelliSense does that to me sometimes. It'll put a right squiggly, and then it'll say something incomprehensible or like wrong, and then it'll just go away if I hit save without changing anything. Yeah, so this is all no-brainer forwarding. Config free the config. Here's a little bit more work here. CTX, read CB, write CB, CB arg, server name. CTX, bufflen. Like I was saying yesterday, this I think is dangerous because if you put that a capital letter, I believe according to the standard, this is a name you should not use. It's a reserved word. Reserved for the implementation or some such thing. That's what I remember reading, which made me think I'm not going to use that convention anymore. I don't want to write code that could be a problem later because of some non-standard thing I did. Alright, so there's our default shim. Making sure everything builds. Oh, right, because we're exposing the types of the underlying thing, we had to expose the fact that we're using TLS in the first place, which means including TLS header. That's the price we pay. If you want to, I guess you could move the shim to another header file. Actually, I like that idea. Let's move the shim to another header file. So back to here. Copy that and we'll say TLS shim. That way, if you don't care about changing the shim, you don't have to depend on the TLS headers at all. So this copy paste, that's TLS shim. TLS shim and source TLS shim CVB. Okay, it's 2:30. I'm trying to keep my mind on the time and try to end at a reasonable time according to my schedule, which would be in half an hour or so. Oh, it didn't reload. It does that sometimes, so reload. Reload manually. Okay. Here we go. So the shim. Okay, this module declares a TLS shim. Oh, did the other file say functions? It should say class. Class used. Hey, Riley Monkey. Got my mind on my money. My money on my mind. It should be time. Mind on my time and time on my mind. Used to place a shim between the TLS Decorator class and the actual TLS library in order to support redirecting calls to a mock layer for testing. It's the only reason we're doing it. Oh, copyright is bad. This is brand new. I can't say it's 2016. Okay, here's the only thing that should require TLS. We can remove everything else. Strike everything else. It's just the shim and the one that's selected. Nice and clean. And then this is where we put the default, the base class. Should only need these. We need to include it again because we're actually calling the real functions. We don't need to expose the name of it. We only need to do that much. Alright, so then in the original decorator, I can remove TLS.h, remove the shim, here I still need it? No. Here, I will include the shim. It's actually no longer directly dependent on TLS. Not really. Okay, remove the shim. And remove this. Testing latency seems over 20 seconds? Really? 8 seconds now, huh? So sometimes the delay can build. I remember other streamers pointing that out, that sometimes you gotta refresh. And who knows, that could be my end, your end. I mean, according to my dashboard and everything, we've been consistently 2 megabit per second without any drops. Yeah, drop frame 0, so dunno. Alright, so I think this will now, will this actually work? It does, but we have to be careful. We gotta go replace all of the calls to the real TLS. So instead of TLS right, it's selected TLS shim, right? TLS right. I sound like one of your teachers? Oh, hi there, Offbeat Jenny. Maybe I am one of your teachers. You know, it's possible. Who knows? I might be using a fake name. Doubt it though, because I've never been a teacher. I thought about teaching. A couple problems with being a teacher though. You need a lot of credentials or experience before like you can get hired in a good teaching position. And it really doesn't pay well, and it's really a tough job when you think about it. Especially if you're being held to standards that really, it's not something you're completely in control of. Like if you have students and you're responsible for them succeeding, but they don't put in the time and effort, it'd be kind of frustrating and difficult, I think. Math teacher. My brother is the math guy. I don't know much math. So yeah, we're just going through this code I wrote yesterday, which adds support for secure connections, and I've separated the code both at the top layer and the bottom layer to kind of make it reusable and more professional. We're doing the bottom layer here, where instead of calling the real library TLS library calls, we're going through a shim layer so that we can redirect things to a test framework if we want. I think that'll do it. Okay, I made some mistakes, obviously. Let's see. What did I do wrong? Oh, I didn't include its own header. That would be a problem. Actually, it shouldn't include that one at all. This should include that. That's probably it. Okay, just one thing. Okay, external symbol, select a TLS shim. Oh, is that because this is inside this namespace, maybe? Or did I not declare that as extern? I did. Okay, what am I doing wrong? It's within the TLS Decorator namespace. This, not the same. Oh, yeah. I misspelled it. That's what it was. Cool. All right. So, of course, we still haven't gotten to... We haven't written any tests yet, so I have places for it to put the tests, but there's no actual tests there. They're all empty. It's time to fill them in. Oh, no, wait a minute. One more thing. All these things, all these prerequisites. Before I can actually test a thing, we actually have to make the redirecting shim. So I'll take the real shim, and I'll just have it do something else. Okay, so let's put the fake shim here. And say this is an alternative TLS shim which mocks the lib TLS library completely. Okay, so it's going to be let's make it a struct, so our test can reach in and use it without formality, and we'll call it TLS, mock TLS, and it's a public derived class of TLS shim, a TLS decorator TLS shim, which means we need to include that header. All right, and then just a little bit of a formality here, saying that these methods really come from that base class. So here were the base class methods. We're going to say that they're virtual and overridden. Yes, that's what we do, right? And oh, we remove that. So we're going to do that for every one of these methods. A little bit of tedium. But let's see if I can get it through quickly. And override. Override, override, override. And one more. And then we get rid of, actually that I can search replace that one. Search replace. TLS shim : goes to nothing. All right, so now we're free to do whatever we want for these different methods. Oh, I guess I missed a few. Must not have had them selected. Okay, so we have this convenient fixture in which we can redirect the selected, it's a TLS decorator, selected TLS shim equals, and then we can redirect it. We actually need to make one though, in case we have state. So we'll make it a property. This holds any state in the mock shim layer used to test representing the TLS library. All right, and then we just say it's the address of that. Actually, I'm going to make it static so that it's constructed outside the fixture, just so that after teardown, if something continues to try to talk to it, it'll still exist. All right, so now we can actually write the tests. Which one do I want to write first? Oh, maybe not. I'm missing something still. I am missing... Oh, okay. When you do this static thing, that just declares it. You have to actually provide storage for it. You have to say, again, the name of the structure, colon that. One of those weird rules in C and C++, right? Oh, I guess we need to actually return something from these things, right? What is the code for? So I have a attempt at artistic brilliance. And this sort of describes the network stack between our web client, HTTP client, and the actual operating system, right? So your operating system lets you make network connections through something called a socket, but each operating system is different. So I made this library system abstractions, and there's a class in there called network connection, so that its API, which we worked on today, we made it a real API, is the same for each OS. So this part was already done. In addition to that, I have sort of an adapter between generic network connection and then what our web client expects, and that's called HTTP client transport. And there's a class HTTP connection. So yesterday I added secure connection support by adding a decorator between these two. So what a decorator does is it just adds another box. You can think of it, there's another box here. Same interface, HTTP connection, but then it's sort of like a man in the middle. So today what I'm doing, what I've been working on, and what the code is for is it's this decorator, and we're moving it to a smarter place to put it in the stack, which is lower, one layer lower. And that way our decorator for TLS is transport layer security, by the way. Transport layer security stuff can sit between the web stuff and the socket stuff. And then you could reuse it for non-web stuff as well, like shell access or FTP. I don't know, what else do you use TLS for? Email, secure email. So all the code today, what it's for is for secure connections, and I'm basically wrote it yesterday and I'm just moving it around in my network stack today. So I hope that gives you at least a little bit of an idea. And in general, how this fits in to the rest of my stream. I have a nice diagram, not a crude drawing, in my overview high-level diagram. So it's what, stream 54 today? So back on stream like 1 and 2, I was writing really low-level components to do stuff you need for web servers, like parsing JSON, URLs, Unicode, hash functions, stuff like that. And I was sort of building these up, and I don't know, around stream 40 or 30 or so, I actually got everything up to where I actually have a web server running. And recently I've been doing the client side because I think it's easier to use a web client to test stuff like secure connections, which is the subject of this week. And when I get that working, I'll put it back into my web server, and I don't know, at some point I'll wrap up this work, but the last 2 or 3 months, my stream has been about making a web server from scratch in C++, mostly because it's fun for me, and I get to show how test-driven development is used. So I've been building up towards that, in that before I really finish my TLS decorator class, I'm making a bunch of tests that document and set up what are the expectations of the class. And we'll see them fail, and then we'll fix the class to meet the test requirements, and then see it pass, and then that sort of describes the whole process. And it's fine if it sounds complicated. I think in general, most things sound complicated at first, but if it's interesting to you and you follow it and learn about it, it'll stop sounding complicated and it'll start to click. But Yeah, feel free to stop at any point. If you have like random questions in C++, I'll try to answer them. But it's going to be kind of complicated because what we're doing is about at this level between low and high. If you look at my earlier streams, which are I'll archive them in YouTube, like when I was working on JSON or base64 or URI, that code is a lot less complicated. As you move up in what you call this integration path, the highly integrated components, they're the most complicated. The ones at the bottom being the least complicated, usually. So yeah, the fact that we're sort of in the middle, maybe towards the upper, in this stack, it's going to be a bit complicated looking. So yeah, apologies if it gets a little confusing. But yeah, stop me if you've got questions. So we're going to lay out the requirements here. So I think minimum requirements for diagnostic subscription. We want to be able to subscribe. So I want to say, hey, Decorator, I want to subscribe to diagnostics. And the way we subscribe is we give a function to be called when there's a message. So let's give it a function. I'm going to look at the declaration of this method to see what is the type of this function. Here's the type. So it's a function that returns nothing and takes 3 arguments. So we fill that in. Those are the arguments we're going to get. And we get to do whatever we want in there. And then there's a second argument, minimum level. I think we'll just leave that at the default. So by the way, if you're not familiar with this syntax, this is what's called a Lambda expression, sometimes called an anonymous function. It's a function with no name, and instead of a name, there's what's called a capture list. And there you put what variables from outside of this block you want to have access to. So if, in this case, I'm going to have, let's make it a vector of strings, captured diagnostic messages. If I want to have access to that variable, I need to list it here. Furthermore, if I just give it the name, I'll actually just capture a copy. In this case, I want to capture a reference, and you put a little ampersand in front if you want to capture a reference. Because what I want to do, if this function is called, I want to take that message and append it. So capture diagnostic messages, push back, and let's make it a construction. I have a little helper thing called system abstractions Printf. It's like the C function Printf, only it's gives you a C++ string instead of a C string, and you don't need to give it a buffer. It like automatically makes one, so it's kind of nice. We'll say we'll have the string bracket and then the level and then the message. So sender name, and sender name's a C++ string, but sprintf needs C strings, so we do C string, level, and then message C string. Right. So the idea here is that we're going to say, hey, Decorator, we want to subscribe to diagnostics. Whenever there's a message, call this function. It will call, and we will take the message and push it into our vector so that afterwards we can do something like, we need to do something that would cause a diagnostic message to be called. So how about, I don't know. We'll just put one in there just to test. We'll say close, and then we'll expect that. And the unfortunate little extra crud you have to type here, and this is mostly an issue with Visual Studio, Google Test. But you have to do that, and then I like to, for these expectation checks, this is part of Google Test Framework, by the way, it's expected value and then actual value. So the actual value is going to be what we captured. And then what we expected it to be would, let's write down what our expectations are. Let's say we expect one function, which is close was called, right? So I can build that and run it, and well, I should be able to. Oh, I forgot to do this. Minimum, we need to return something. I'm following test-driven development. I should say. you try to do the minimum you can get away with at first, just so you can see your test fail. And then you put the real code in there to make the test pass. Don't need that. So I need at least something to get the code to compile. It's not going to actually pass the real tests until I put something real in there, right? Okay, so let's run, if I run the test now, you can see, okay, it actually failed, but it failed in a way I didn't expect. There was an exception thrown. So let's see what that exception was. I'll show you a little debugging technique I do a lot. Find the test runner. So it's Decorator test. Right click, say set as startup project, and then go. I sound like a teacher? I'll take that as a compliment. Thank you. So here's where the exception is thrown. Oh, I believe it's because lower, so when you mouse over it, it says empty. That's a null pointer. So there we go. There's a bug. What we should do in close is make sure there is a lower layer. So if impl lower layer is null, we should probably just return. Alright, so that should fix the crash. Now we get the test to fail, and it's basically telling us we expected this. This is what we actually got. In other words, we didn't capture any messages. So to fix the test, I gotta meet the expectations, which we wrote down here. We expected that message. We have to actually generate that diagnostic message. Oh, thank you. I appreciate that. So this will replace this old printf that I had in there. So let's go and remove that. So we have this diagnostic sender, which is our utility for generating messages. And it's send, we can use send diagnostic information string. And we get to pick a level. I don't know. What level should we expect? Actually, what did we expect here? Oh, this is going to be wrong anyway. It's got to follow that format. So it'll be the sender name, which is TLS Decorator. And then in brackets a level. Let's make it level 1. So to meet that, we have to say it's level 1. And then the message is close was called. Oh, I was going to have it replace the printf, so let's remove that. Don't know if I'm going to finish this class today, because I tried to only stream for like 3 hours. Let's see how far I can get. So that made our test pass. So if I had goofed up and I had maybe misspelled that, we'll see it fail the test again. And that's called a regression, by the way. If a test was passing and then you like accidentally screwed up the code, the test that you had before passing now fails, that's now a regret. It's called a regression because you're regressing. You're going back from a good state back to a bad state. And that's one of the benefits of test-driven development is as you build up lots and lots of these tests, you're basically making yourself a database of checks that are always performed every time you change your code. It'll recheck to make sure nothing broke. So we're back up to running, and you'll see as I stream, some of these that have a huge number of tests, like this one. I always get nervous when I run it because there's so many tests. If they all pass, I feel good. If one of them breaks, then I'm like, oh, okay, I accidentally broke something. We can go fix it. It's sort of like a double check or a sanity check. So one of the benefits of this process. If we didn't have all these tests, then every time we change the code, we might break something and not know it because we just simply aren't running that piece of code. All right. I think that's good enough for testing that diagnostic messages work when we subscribe, but let's make another one where we test unsubscription. So here we will subscribe and then we will immediately call, actually this returns the function to unsubscribe. So it's const auto unsubscribe equals that, and then we can call it unsubscribe. Now when we close, it will generate that, but we won't get it because we unsubscribed. So it'll be like that. So, and a lot of the times you'll want to see the test fail first. And one easy, quick thing to do is to simply expect both true and false, and then it'll definitely fail. And that's like a sanity check that your test is actually being run in the first place. So that failed, I put it back. So in other words, our code was already compliant, even to this new requirement I added, that unsubscribe work. All right, so that's it for those tests. Okay, connect forwarded without starting TLS. So the forwarding implies that we can actually have a lower layer. So we need to actually have a mock for that. I forgot to write one. Let's write it real quick along with this take. I think what I'll do is I'll write this, I'll complete this one test and then wrap up the stream and continue on Monday. So we're going to have another mock here. A mock is a substitute for something that you're not testing, but that is needed by the thing you're testing. So this is a substitute for a real connection and used to test the TLS decorator, which needs a connection to decorate. I don't know if I mentioned it this stream or not, but Decorator, you can look up Decorator pattern, and that's what I'm employing. So it's a class that you put in front of another class and changes the behavior. I'm sure any guide you can look up online would explain it better than I could. I'm not very good at explanations. So I like to write down links in my OneNote and refer people to online resources rather than try to repeat the descriptions myself. Okay, so this is a mock connection. We're going to implement a network connection. I have a feeling I've done this before, so let me search for this. Although I think maybe it's all in the context of the upper layer stuff. Yeah, it's all HTTP stuff. Yeah, this is the first time I'm mocking this particular interface, which is fine. It's not a big deal. Let's see. I think I've been talking a lot more in this stream, so my voice is getting sore already. Oh, why am I in the HTTP library? I should be in the System Abstractions library. That's where this thing is. I'm going to copy from the concrete class the overrides. This is a shortcut because we're also providing a concrete override. It's just one that will not do anything real. Okay. So it's the same thing like the mock TLS. We have to do something, but we'll start off by doing nothing. And we'll modify it as we go to help. Basically, the mocks are the helpers of the test. They are there to capture side effects so that the test can inspect them. Okay, so we need some kind of unsubscribe delegate. Actually, you know what's better than returning null is returning something that does nothing. So here was the signature of the diagnostic subscriber, right? So if we just have it do nothing, no capture, doesn't do anything. Oh, it's the other, I'm sorry, it's this one we have to implement. Oh, okay, that's even easier. That's just that. An empty function, right? It's not null, you can call it, it just does nothing. That's called the null object pattern, by the way. I know some people at my last job who were really into avoiding null pointers, instead just using null objects instead. So you get a pointer to an object always, it just wouldn't do anything if you called its methods, and that's called a null object. Better than a null pointer, because if you dereference a null pointer, you get a crash. If you use a null object, nothing happens. Okay, so there's a mock connection. Let's put one in our fixture. And we'll say, this is used to simulate an actual network connection, which is wrapped by the TLS decorator. Alright, so now that we have a mock connection, this connect forwarded without starting TLS, is we can say decorator configure, and then we can, oh, it needs a shared pointer. Oh, that's fine, we can just make one. You can take an object and turn it into a shared pointer pretty easily. If the object is guaranteed to live longer than the pointer, you just do this. So you say mock connection, you give it the address of the mock connection, and then you just give a null deleter. So mock connection, like that. And then server name, how about, since this is a Twitch stream, we'll say it's Pepe. Because why not, right? Okay, so what we're mostly interested in, that connect gets forwarded without starting TLS. So that's two things, right? The connect needs to be forwarded. TLS is not started, so, and that's when we call connect. So let's call connect. And it doesn't matter what we pass in. So let's pass in 42 for the address and 99 for the port. And then it's going to return something. We will actually not care. We just want to expect true that mock connection dot connect called, and expect false mock TLS dot what would we call starting TLS? I guess that would be TLS connect called. Okay, so those have red squigglies because we haven't defined these symbols yet. So let's define them. So connect called is in mock connection. And mock connection is here. So let's list our property. Let's list that as a property. And we'll initialize it to false. We set it to true if this happens. We should probably return true because the unit under test will probably croak if we tell it the connection failed. Okay. We could also capture, let's do that. Let's capture the actual arguments. Peer address given, and then peer port given, and then we will say that equals the peer address. This equals the peer port. And then in the test, we can just check it, right? We can expect equal 42 for mock connection dot peer address given, and expect 99 for peer port given. Okay, now TLS needs a TLS connect called, so up here. Properties. And where the TLS shim is called, or connect here. So we say true. All right, so we're ready to run that test. So if I hadn't written the code, it would fail. So we are adapting code I wrote yesterday during while we were experimenting, so it actually might pass. Let's see if it passes. It passed. That's probably because the connect was very simple. Yeah, see, it already did that. But let's say it didn't. Let's say it just pretended to connect. Okay, but didn't actually connect. Now that'll fail our test. And it fails in 3 ways. So it'll say, well, connect was never called. And the addresses weren't given. That's another thing, right? If we forwarded it, but we ignored, let's say we ignore the port and we just always send 80 or something, that would also fail our test, but in a different way. It would be, well, we expected 99 to be forwarded through, but we got 80. So, yeah, probably continue on Monday. It's going to be more of this stuff. So, if this is not interesting, that's fine. I'm not offended. But we'll be going through and setting up all the rest of our expectations for how this decorator is supposed to work. And once it all works and is passing, then I'll plug it in back into our web client. Right now our web client is using the old way of decorating, and where it only works for a HTTP connection. And if you haven't seen it, let me run it real quick. So it's called Rover, because you know Rover fetches things. And you just give it the address of something. So if we say google.com, right? It actually fetches the web page, and we don't have a graphics API for it, but it basically says, well, here it was 200, okay, here are the headers that we got, and I'm just glancing through it to make sure it's all good. Yeah, so there's no personal info this time. But yeah, and if I misspelled that, like, well, let's go to something that should never exist. Example, this should never exist. And then we say it gets unable to connect, right? And if like we say go to that server but use a different port number, like, what's the I know what we can do. We can use the port for SSL or HTTPS, right? 443, right? That was in there somewhere. I saw it scroll by. 443, right? But not with an S here. You'll get a message that interesting. I actually expected the message saying you're connecting with the wrong protocol, but I guess Google is smarter about it. Oh, it was wikipedia.org that did that, right? Yeah, they said, you made a plain request, but you sent it to the secure port. So, not tomorrow, but Monday, we're finishing up this decorator and in the clean style where it's decorating at the correct place in the stack, and we'll plug it back into Rover and make sure it's still working. Now let me go back to my plan. See. So we got, the plan was pretty unspecific. I really should have kind of laid out the different steps I would need to do, and then I could track how far I got into it. So I got somewhat into the middle of my 1-bullet plan. So we'll try to continue and finish this up on Monday. So yeah, I hope you enjoyed watching, and I kind of like hosting Adam when I'm done. It kind of works out that way. I can watch him for a while too. So we'll go. Let me go just really quickly see if he's still on. He should be, unless he got really tired. Okay, open that in a new tab. Yep, he's still going. So if you haven't seen Adam, I'll introduce you to him. He is an awesome guy working on a game in JavaScript. He's been working on it for 3 years now. It's coming up on the 3-year anniversary, so I hope you enjoy watching him. And I'll see you next time. Thanks for watching.